Hello viewers, welcome to our channel Flexomaster. Today we are going to study the chapter number 18 for paper and paperboard packaging, which is normally called it as folding carton or paperboard box packaging, etc. etc. So please continue. Thank you very much. Paper and paperboard packaging. Introduction. Paper and paperboard are made from cellulose fibers extracted from trees combined together with additives to make it continuous matted web. This chapter covers the raw materials, process, and on and offline treatments used to manufacture fibrous substrates, paper and paperboard, used for conversion into packaging components. These components include wrapping materials, bags, sacks, cartons, tubs, lids, molded fiber packaging, and backing cards for various plastic, paper, and paperboard combinations. Paper and paperboard based material is one of the earliest and largest used packaging form for food products like a milk and milk based products, beverages, dry powders, confectionery, bakery products, etc. Owing to its eco-friendly symbol, paper and paperboard can be described as a matted or felted sheet usually composed of plant fiber, commonly from trees or recycled paper or paperboard waste, etc. Example: corrugated boxes, newsprint, sacks, paper bags, and cartons. Paper and paperboard are most common packaging raw materials. Paper is used mainly in corrugated board manufacture, spiral tube making, and also in laminates, sacks, and bag manufacture. And wrapping material for such products as a ream wrap for copier paper, paperboard is used mainly in cartons. There are many forms of paper with a variety of properties. These properties are further utilized with the help of other materials when combined together in laminates, coating and polymers also enhances the properties of paper. These coatings vary from fluorocarbon grease resistance to water-based and film-based barriers coatings, grease water, water vapor, and gas barrier, making the paper base a suitable, versatile material indeed. Paperboard, though not quite as versatile on its own, can benefit from coating and lamination with polymeric materials and aluminum foil and vacuum deposition in the same way as paper. Properties of paper and paperboard. The properties of paper and paperboard depend on many factors, can be tailored to meet the specific needs of the packaging industry. The source of fiber, the type of fiber, how the fiber is extracted from the source, the amount of treatment the fibers are exposed during the pulping process, how the fibers are combined together, how the fibers are converted to paperboard, and type of mill used, the term given for the machine on which the paper and paperboard are made, the number of plies used to make up a paper or paperboard sheet, what performance additives and process aids are used, whether or not the paper or paperboard is bleached, coated, or combined with other materials. The main properties of paper and paperboard to be considered in packaging application as follows: stiffness, printing surface, absorbency, burst strength, tensile strength, tear resistance and compression strength, grease resistance. Excellent stiffness, some tissue paper accepted and dead fold of all papers and paperboard, especially bleached and unbleached craft and sulfide grades allow very lightweight papers to be used for bags, ensuring their creases are sharp and they stand erect on shelf. The downside is the paper keeps its crease when deformed, detracting from its aesthetic appeal. The use of a sandwich of mechanical pulp between chemical pulps, known as a folding box board (FBB), maximize the stiffness obtainable for a cartoon and provides good dead fold when creased. The density, whiteness, porosity, and smoothness of the bleach paper and paperboard, especially sulfide grades, portray a bright, high quality print when decorated by an offset, lithographic, flexographic, gravure, or digital process. The main properties also it covers and explain you. The SBB is a solid bleach board. Then you have FBB, folding box board. Then WLC, white line chipboard. It shows where the applications are courtesy is taken from Eggleston paperboard. Now the paperboard grades. Grades of paperboard used can generally classified as follows. Solid bleach board SBB paperboard made from virgin bleached chemical pulp. Again, solid unbleached board paperboard made mainly from unbleached virgin chemical pulp. A layer of bleached fiber is sometimes added to a top to provide greater whiteness. FBB folding box board made from a layer of layers of mainly virgin mechanical pulp sandwich between layers of virgin chemical pulp. The top layer is bleached chemical pulp and the bottom layer can be either bleached or unbleached virgin chemical pulp. White lined chipboard WLC made from the multi layers of recycled fibers. The top layer can be made from bleached virgin chemical pulp or white de-inked recycled fibers. Between the top layer and the middle layers, there can be a layer of chemical, mechanical or de-inked recycled fiber. The bottom layer can be made from selected recycled or bleached or unbleached virgin fibers. There are other brands available which are combination or variation of the above. These two examples are CCNB, clay coated newsback. Newsback refers to the layers of pulp beneath the coating made especially from recycled newspaper rather than mixed waste. This creates a very smooth light gray underside, but due to the short fibers, these material can only be used where the physical strength of the cartoon is relatively unimportant. Another type, CCKB, clay coated craft back, also known as CKB in Europe and coated craft back, or CCCB, clay coated craft back in the United States. Craft back can refer to virgin sulfate unbleached pulp or fiber recovered from used corrugated cases. This is much stronger board than CCNB and in some instances can compete with craft board. Changing properties by combining paper with other materials. Paper and paper boards, when combined with selected polymeric film materials, can result in materials with significantly enhanced properties. Coating with polyethylene and other polymer film makes it possible to heat seal paper-based materials, which is very useful in sack and bag manufacture, where an integral seal is required, for example, for dry pet foods. Aluminum foil and polymer films can be added, allowing laminates to constructed that can be formed into liquid packaging cartons. In this application, the paper provides the stiffness, puncture, and abuse resistance for mobility on the packaging machine and adds to the ultraviolet UV light barrier. The aluminum provides the gas, UV, and water vapor barrier. The polymeric film, usually polyethylene or polypropylene, provides water and product resistance. Acts as an adhesive between the aluminum and the paper and provides an excellent heat shield to ensure the product does not leak and there is no ingress of gas through the sealed surface. The negative aspects of combining the paper with other materials are that it makes the waste more difficult to separate and therefore recycle into its component parts in a commercial variable manner. Water-based barriers coating WBBC has been developed to overcome some of these issues. They provide water barrier, some water vapor barrier, grease barrier, and product release, and are claimed to be fully repulpable with the paper, negating that need of separation of the coating from the fibers. Raw materials. The main raw material used to make paper and paperboard is cellulose fiber sourced from trees and recycled waste. Fibers are mixed with additives to improve performance and control process, and where necessary treated with coatings to further improve performance. The source for and treatment of, of these raw materials and how they influence performance will now be discussed in this section. Fiber length is one of, if not the most important, property with respect to paper and paperboard performance. And the length and space shape of the fiber depends on the source. Deciduous trees, that is broadleaf trees, which lose their leaves in the winter in non-tropical regions, produce short fibers, whereas coniferous trees, cone-bearing, needle-leaf trees produce long fibers. Deciduous trees are also known as hardwoods and coniferous trees as softwoods. Short fibers provide smoothness for printing, while long fibers provide strength. Typical ranges of fiber length used in paper making are: number one, short hardwood fibers 1 to 1.5 millimeter in length; long softwood fibers 3 to 4 millimeter in length. Trees of a selected species are grown to a specific size, felled, cut into precise lengths, the branches, twigs, and some of the bark removed, and the logs transported to the mill to be converted into paper and paperboard. Once the debranched trees reach the mill, they are completely debarked and sent to chippers, where they are cut to similar sized small pieces before they are sent to the predetermined pulping process. Recycled fibers vary widely depending on the waste raw material source. In general, they are a mixture of hard and soft woods. Their fiber length depending on the number of times they have been recycled. Fibers are shortened at each recycling process, and once virgin fibers have been recycled around 7 times, the fiber length is considered too small to use further. The conversion process for paper less than 250 GSM. The most common papers used in packaging and typically end uses are craft bags, sacks, folding cartons, corrugated liners; sulfide bags, sacks, folding cartons, doll ovenable trays, liquid packaging, labels, leaflets, corrugated liners; CTMP, corrugated fluting medium, liquid packaging containers; test liners, mix of virgin and recycled fibers; corrugated liners; recycled craft, spiral wound containers; grease proof, glassine and parchment wrappers and bags, where grease resistant is important; tissue, tea bags, industrial packaging, fine jewelry, textile. The main packaging formats using paper are corrugated packaging, sacks, bags, spiral, linear and convolute wound containers, liquid packaging, cartons. Paper sacks. A paper sack can be differentiated from a paper bag by its product weight, which is usually above 5 kg, and in fact, that is traditionally made from more than one ply. In the United States, paper bags are used as a grocery bags, referred to as sacks. Paper sacks are traditionally made from the between 2 and 6 plies of paper, sometimes having one plastic film ply to resist the ingress of water. For example, cement sacks for use on open air building sites. Modern developments in sack craft papers have led to some sacks being produced from one ply heavyweight craft 120 GSM. The sack manufacturing procedure is straightforward. The plies of papers fed from separate reels and passed through a tubing machine where each one in turn is glued with a water-based emulsion adhesive to produce a multi-wall tube in which each ply is free of mover independently. The freedom of movement of plies allows the sack to remain flexible and absorb the bursting forces which would otherwise rupture a more rigid construction. The tube is cut to size and the bottom formed and sealed. Sealing can be stitching, pasting with adhesive or heat sealing, where hot melt, polymer film or other heat seal coating is incorporated into sealing surface. This is wide range of sack design starting from simple open mouth to bottom block bottom gazetted wall sacks. Open mouth sacks can be supplied as seven flat, A seven gazetted, B pasted flat, pinched closed flat, D pinched closed gazetted, E pasted double folded flat, F pasted double folded gazetted, G plastic film layers can be included, and if this plastic film is the innermost ply, the sack can be heat sealed. The non-gazetted version are like a pillow in shape when filled and therefore require care when being palletized due to this instability. They are commonly used for packing of animal feeds and powder foods and ingredients. Here I am showing you that open mouth sacks which I have explained. Number A is C1 gazetted, pasted flat B, C pinched close flat, D pinched close gazetted, pasted double folded and pasted double folded gazetted, and plastic filling layers can be included here. Now come to paper valve sacks. The other main sack design in the valve sacks, the typical design are sewn flat, pasted flush cut flat, and pasted stepped and flat, and so on. Valves can be internal and can be constructed of plain paper, polymer coated paper, or a layer of polyethylene film. During the filling operation, the valve is located on the filling nozzle and the product dispensed into the sack. Usually the vibration of speed up the process. Once filling is complete, the valve is closed. Internal valves without any polymer layer really rely solely on the weight of the product to close the pack at the valve end. While this is effective for some purposes, it does not prevent a degree of leakage and possible ingress of contaminants. Also, it is not tamper evident. A more effective closures is achieved by heat sealing, which can of course only be carried out when polymer coated paper or polyethylene film have been used in the valve construction. Sacks with external valves are closed by folding the protruding valve section and tucking it inside the sack. Again, accompanied by heat sealing, if the wall construction allows, the folded section can be secured by applying a self-adhesive tape or label. Thus, external valve provide easier and more secure closing, although they are slightly more difficult to load onto the filling nozzle, especially on high-speed filling lines, and they use more materials. Valve sacks are used for packaging of granulated and powder products such as sugar, plastic pellets, and cement. Compared with open mouth sack, valve sacks provide a faster means of filling but must be vented to allow the displayed air to flow out as quickly as product is entering into the sack. Some sacks are perforated to allow for this, but recently sack crafts have been developed with a porosity which allows the air to dissipate through the single ply sack wall at an acceptable rate. Filled valve sacs are more regular in shape than open mouth sacs, thus as easier to palletize in a stable loads. Paper valve sacs, and these are the design of the main sac in valve sac. Number A is Seven gazetted, all right, and number B basted flush cut flat, and C stepped end flat, D pasted and seven, and E is during manufacture one end of the valve sac is completely sealed here, while the other has filling spout of valve built in. So we will stop here and we will continue to our chapter number 19. Hello viewers, so we have completed the chapter number 18 for paper and paperboard packaging, and we will continue our next chapter on the same subject. And for this you are requested to watch our next video and like our channel, share our channel and comment, and looking forward to see you again. Thank you.